add or subtract radicals, here's the deal. The number under the radical, the number under the radical has to be the same to add. Has to be the same. So I'm actually going to go over this one on the top right first. Can we agree that the same thing is under each radical? What's 9 minus 3? That's the answer. It's that straightforward. The first one, though, obviously you don't have the same number of the radical. Guys, I'm really going to give you a question where you can't get it where you have the same number of the radical. Let's be smart about it, right? Let's see if we break 12 down, what happens. We get 2 and 6, we get 2 and 3. So that becomes 4 times 2 root 3. Plus, with the 27, 3 and 9, 3 and 3. That becomes 7 times 3 root 3. 8 root 3 plus 21 root 3 equals 29 root 3. We got to get the same number under the radical, and then we can move forward. And it becomes a much simpler. The only difference on the bottom two is they're a little bit more complicated to simplify. 18x cubed y. Well, 18 breaks down 2 and 9, 3 and 3. In addition, because there's no index here, it's assumed to be 2. 3 divided by 2 is 1 remainder 1. So I'm left with 12 times pair of 3's, and I can pull the x out, square root of 2xy. Minus 2 times, and we'll see in a second what it's going to look like. All right, 32. 2 and 16. 2 and 8. 2 and 4. 2 and 2. Pair of 2's with a 2 left over. So that's 4 root 2. X cubed becomes x root x. So this is 4x on the outside, and in the radical is 2xy. Here we get 36x, radical 2xy. 8x, radical 2xy. 36x minus 8x, 28x, radical 2xy. And get used to the fact you're going to get answers that look like that. They're going to be complicated looking answers with radicals. Usually that's one of the things that happens that makes it difficult with radicals and fractional exponents is you get complicated looking answers. All right? I'd be more concerned if my answer was 3. It should be a complicated looking answer. Second one, I'm going to break down that 16. 2 and 8, 2 and 4, 2 and 2. But it's a cube root, so it's 4 times 2 cube root of 2. 54, 2 and 27, 3 and 9, 3 and 3. So it becomes 5, 3 cube root 2. Once again, we get the same number in the radical. 8 cube root 2 plus 15 cube root 2 equals 23 cube root 2. And that's our answer. All right, I think the hardest thing to do is deal with the numbers. So if I deal with 64 here, 2 and 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. 5 2's. So this 2 goes on the outside in the 5th root, and we have this 1 extra 2 on the inside. It's simply this. It's 9 divided by 5. 1 remainder 4. 11 divided by 5. 2 remainder 1. 15 divided by 5. 3 remainder 0, so the 0 doesn't go in the radical. We're we're literally going back to division when you were in 4th grade, where you wrote the quotient and then the remainder. And it's weird because we don't really do that anymore. This is one of the few spots you'll do that. Okay? 54, 2 and 27, 3 and 9, 3 and 3. The 3 goes on the outside and the 2 goes on the inside. 14 divided by 3, 4, remainder 2. 16 divided by 3, 5, remainder 1. And z squared, anytime the exponent's less than the index, we just leave it in the radical. And that's it.